Everyone, and welcome to our crash course on generative AI. My name is Lassigis and I'll be your host this morning. What we want to do in the next 90 minutes or so is take you through ours and our customers' journey from concept to value with generative AI. I should start by saying I'll be probably referring to it more with the short version, Gen AI. I find that I get my tongue tied up if I try to say generative AI too many times, so bear with me. I'll use the short version. Hopefully that's okay. So why are we here? Is there a need for another session on Gen AI? Do we need more noise around this whole buzz and hype around Gen AI? We felt that we do, but what we want to do is be more practical, be more pragmatic, and be more serious about it. So at Solita, we're very excited about Gen AI. We're actually so excited that we take it seriously, and we want to help you to take it seriously as well. So what do we mean by taking it seriously? There's a few things. Obviously, we want to look at both the pros and cons, the upsides and downsides of Gen AI, the opportunities and also the risks involved. And we also want to be really practical about it. We want to learn and share our learnings on how to make it work in real life, in real settings. How do we run Gen AI projects? How do we deliver them at scale, sustainably, economically, and all of those things. So that's why we're here. We won't be showing any ChatGPT prompting, I can assure you. Instead, we'll talk about what it's like in the real world. So our objective for today is, as we said, take you through our journey, get you from hype to practice, learn about what it's like doing Gen AI in real life. If you haven't already, hopefully this session will get you started on your journey. That's our number one goal. The second one is to help you avoid the common pitfalls. So we'll share some of our deliberation and decision making in these projects, and especially in a specific customer project. And what we want to do is obviously demonstrate how to create real value from the Gen AI hype. I should tell you there's a chat functionality in this tool. Please ask questions during the session. We have time in the end for Q&A, but please ask questions during, and we'll be monitoring and moderating those, and we'll pick the best ones for the end. Before we get started, just a few quick words on who we are at Solita. We believe the world is hyper-connected, obviously, and we believe that we can create lasting impact if we know how to work with data, with technology, and with human insight. That's what we do, and you can see some of our numbers here. We're a steady growth company operating now in 6 different countries. We have 1,700 plus employees at the moment working with software development, strategy, data and AI, design, cloud and connectivity. So the full range of offerings that also relate to artificial intelligence. And I mentioned we're in 6 different countries. We have multiple offices in all of the countries, and we do customer work in all of these offices, so they're not just sales offices. And the customer work we do in all of these places, that ranges across multiple industries. We are industry agnostic. We learn from the best practices from various industries, and we can share those amongst each other. That's one of our strengths. We also work with public as well as private, which means we're familiar with regulated domains and regulated industries. We know how to solve really complex and difficult challenges as well. That's one of our strengths, and that is what makes us robust and resilient in all of these changes in the market dynamics. So in short, what we want to do at Solita is create impact that lasts, and we believe that that happens when we know how to work with technology, with data and human insight, and in this case also artificial intelligence. That's who we are at Solita. Now you'll be hearing from 3 much more knowledgeable experts than me today. So first off, in this session, we have Satu, our machine learning engineer, who will give you an introduction to generative AI and put it into its appropriate context for this morning. After this, we have Kartik, our AI strategist, and he'll talk about how he navigated with speed through the Gen AI rush with our customer, Tana. And then we have Jyoti, our machine learning engineer, who will talk about the actual Gen AI implementation case at our customer, Tana, and he'll talk you through how we run the project with our customer. And as I mentioned in the end, we have time for Q&A, so please ask questions in the chat during the session. That's all from me for this morning. I'll hand over to Satu, who will give you an introduction to Gen AI. Satu, all yours.
Thank you, Lasse. So, as said, my name is Satu Korhonen, and part of my work is to find out how to do these Gen AI projects or machine learning projects in practice, the engineering part of it. On top of that, I am very curious in phenomena and how it works and what is the groundwork of it and how to innovate in it in safety So this is my viewpoint in how I'm introducing generative AI, and I will also use the Gen AI because it does roll off the tongue easier. But let's get started. I'll start with some terminology and some history, and then I will look at how it actually works, and then in the end, I will have some key things to bear in mind going forward with this technology. So, artificial intelligence. It's a term that's been around for quite a while. It started off in science fiction in the beginning of the last century, and it kind of captured the interest of many scientists that grew up then, and a group of these came together in the 1950s in a conference in Dartmouth to kind of define what this terminology means and what it needs to actually be artificial intelligence. And that definition has changed over the years a bit, but basically what is meant by artificial intelligence is a program that can sense, reason, act, and adapt. So basically, it needs to perform something that, when done by humans, requires some intellect, and then it's artificial intelligence. And many of the algorithms and those that were already developed in the decades that followed, like the first we started seeing like rule-based systems and expert systems that still required coding in how something is decided, but we started seeing that quite early on. Then we had more capabilities in computing and also more data available. And in the 80s and 90s, we started seeing machine learning, which was basically algorithms whose performance could improve over time when they were exposed to more data. So they learned from the data to make their predictions more accurate. Then going forward, like not all that is artificial intelligence can be considered machine learning because that is statistical and mathematical more. And then we go to deep learning, which is a part of machine learning. But not all that is machine learning is deep learning. This is why they are in the centric rings on the screen. So about the 2000, we started achieving many of the landmarks for artificial intelligence. Deep Blue from IBM beat the chess master of the world, and we saw several advances such as this through the help of deep learning. And same as for machine learning, also in deep learning, the history of it goes back to already in 1943 when the first computer version of how a neuron works was developed. And then the coming decades that came, like 60s, 70s, 80s, saw the development of many of the technologies that are the foundation of how deep learning works. So then we come to the generative AI, and in here we have another shift. When machine learning came, we are in a situation where we don't have to code the decisions like step by step and every version of it, because the computer can basically get that information from the data, how it should work. Now, with generative AI, we are in a state where we no longer have to tell it precisely how to generate content. It can generate images, text, remarkably well. So I feel we are in this new watershed or like turning moment in the technology, which is why I'm deeply fascinated in how it works. So there's a lot of terms in Gen AI. First, we have the Gen AI, which is deep learning. It's techniques that learn how the data works. So if we feed generative AI a large amount of text, it learns how language and text work. If we feed it images, it learns how to create images, how to get the output we're asking of it. So whatever data we give it, generative AI learns how that works and then generates more based on the data it has learned. The next term is foundation models, which are these large machine learning models which are trained on unlabeled data from different types. One type of a foundation model is the large language model, which works on text. They interpret and generate human-like text. And these are generalized models, so they are focused on how language works, but they don't have a lot of context, especially when coming to the business applications. So whatever context is needed on top of how language works is something that needs to be added to the model somehow. And there are techniques, and my colleague Jyoti will talk you through the options later today. Then we have examples like ChatGPT here on the screen. There's also Midjourney and a host of other, which are types of these foundation models. ChatGPT is a language model, and the text is billions of words and basically scraped from the net. And it has been fine-tuned from human feedback using a technique called reinforcement learning. Basically, these, as I said earlier, that generative AI is changing what we can do in a very big kind of way. Because we can communicate with natural language to the computer like never before. So they're very effective, and it removes many of the barriers of utilizing these. Another that removes the barriers is the cost-effective computing. We have the computer power. We also have the algorithms. They are for download or use through APIs. They're easy to add to. So we have the computing power to use them. We have the models that are easy to add to applications. And because these are easy to use, and they're more and more, they're on our smartphones, they're in every place we do, so consumers are learning new preferences. They're learning that they can communicate with businesses in their natural language, in an easy way, in an intuitive way, instead of going through forms and processes. So their preferences are changing. So utilizing these is now an option, soon requirement, for serving the customers in a way that they expect to be served. And finally, why this is a big thing is that most of enterprise data is unstructured. It's text, it's video, it's audio, it's images, and these need these kinds of models to gain insights from, and we can get insights from knowledge bases and company documentation and all these sorts of things we can now use to build useful solutions that produce value. So looking at what is an LLM, and I will use the term LLM because, again, rolls easier off the tongue. LLM is large language model. So looking at it, how it actually works. In the screen and slide here, you can see a very simplified version of a neural network. Basically, in here, you feed it a piece of text that is transformed and fed into the input layer, which has a group of algorithms to count what goes further to the hidden layers, which pass it on layer from layer from layer, modifying it until we come to the output layer when it is turned back to text, and hence you have the text output. GPT-3 has 96 layers, so these are massive. And they have about 175 billion parameters for GPT-3, and GPT-4 is even bigger. So these are massive models which are very expensive to train, which is really nice that they're so easily usable. So the data handling, we talk about large language model, but that is a bit misleading because what the model sees in those layers between the input and output is numbers. So how that happens is that, like you can see on the screen with the colorful bit there, that you have sentences. These are cut into tokens, and basically that's the word for the token. It is not always a word, especially like if handling Finnish languages. There's so many of the grammatical cases that a single Finnish word can be many tokens. And this is a single unit of input. And this is also base of a lot of the billing and stuff for if using these through an API. But that is just basically the idea. What we further need, we need to give the terminology meaning for the computer as well. This is kind of what I'm doing now to you, to define these terms, but it would not be feasible to do this by hand. So the technology is called embedding. So in that way, when we take those text, we turn it to tokens, we use embeddings then for the computer, the algorithm, to create the meaning and context of what this word means and what are similar words and what are words that are related to it. And by this way, with tokens and embeddings, we create the meaning from the text. So it's in a form of numbers which the computer understands easily and calculates easily, and then we can utilize it and turn back to words. And Jyoti will go into more detail of the use case and also of this stuff. So still, what makes LLMs and their functionality deeply impressive to me is that what they're doing is that they are predicting the next word that comes out. And they basically, for each word, they select what is the most probable word that comes next. And they have an uncanny ability to produce things that have meaning and are of value. But if we don't create some guardrails, then we can produce output that an organization does not want to produce. So it can be harmful, it can be misguided, it can be absolute nonsense. So this is part where expertise is needed to kind of provide a ways for the generation to happen in a way that is safe for the company and organization to use. And actually, for instance, there have been some cases where this has failed, and the industry is working hard on this, because like already in 2016, Microsoft had to take their chatbot Tay offline after 16 hours because of the output it started to produce, which was not in line with Microsoft values. And so we are working on this, and this is a big area of focus. So coming closer to the end of my presentation and the situation now, what is the landscape we are operating in now as we are building these solutions? This is technology. It is moving and changing and developing very rapidly. And it is being taken into use also very fast. Many companies are interested in it. Many are implementing it. Many are talking about it, that this is something that is wanted and needed and also taken to use. As we are in Solita, also outside Solita, the industry is very interested in developing tools and frameworks to support bringing these into what we call production, which is basically in use. And so the tools and frameworks develop all the time. The things that are best practice today, using tools and stuff, weren't available like 5 months ago. And a year from now, the best practice can look something different from what it is today. The thing that also affects all this adoption, the tooling, the frameworks, is the regulation. And that is coming. The European Union is developing the AI Act, which is supposed to come into effect next year. And a great deal of discussion was caused by the advent of generative AI, which also means that that is included in the AI Act coming. So that is something that, for companies interested in proceeding in this area, I would recommend to look that up and see what that requires. And of course, we are looking that as well, and we are following it closely. And on a similar topic, at the moment, there are lawsuits, because the data used to train these models is data scraped from the internet. So there is a lot of discussion on and lawsuits on the intellectual property, and can we proceed doing like this, that all the data that is on the internet, is it free to use to train these models? So we are following that and see what happens and how that changes, if it changes how those big foundation models are developed. Then we have ethical challenges. The slide says mainly bias and fairness, which is slightly misleading. It is one of them, but not the only one. All machine learning learns those characteristics which are in the data. Generative AI is no different. And as the data for the foundation models is scraped off the internet, we kind of all know that it's going to have fairness issues, it's going to have bias issues, and it's going to have other issues as well. So when we take these into use in a business context, in organizations, in public sector context, in security, we do need to look at that, and we need to produce solutions to make it fair, non-discriminatory, and so we need to look at the ethical challenges to make it sustainable and able to produce long-term business value. And because the data is scraped off the net, it is possible to poison the data very easily. You don't have to hack into anything to create a lot of misleading information. It's the internet. It's very easy to do. So when generating the content with these models, it is always good practice to check the outcome and check again until you can be sure that the output that it creates is something that we want it to create. And as cyber attacks are possible using natural language, that lowers the barriers to try if you can break stuff. So that is also, the cybersecurity of these is also something to keep in mind. Then we have user misuse, always a possibility. There have been some high-profile issues where a lawyer generated the briefing for a court case using ChatGPT, and the ChatGPT made up court precedents which didn't exist, and the lawyer didn't check that they actually existed and handed it over and landed themselves in trouble. So you need to understand why they work. They're trying to predict the next word, and they don't differentiate between information and misinformation. As such, they focus on how the language works. Also, it can share private information, so be very careful how you handle sensitive and private information. This is nothing new, but it is still highly relevant. And then finally, a thing that is a feature and not a bug of this technology are the hallucinations, which is what this is called when a model makes stuff up. They're not good in saying, I do not know. So when they don't know, when they don't have the information, they create. So this is something that we need to check. So when I started looking into this, when this caught my attention in this spring, I had the moment, I think some others may have an expert feel of, okay, how much of my expertise just is no longer, might not be needed. And it has been interesting to see that basically it is more important than ever to understand how machine learning works. Where are the issues? Where are the parts where we need to check and support and put guardrails for these models, so what we give out is sustainable and safe and ethical and produces value. Another thing that is still very, very relevant is finding the business value. These are nice to have, but having something nice to have may not make sense. We want them to actually bring value and help the companies and help businesses to do what they need to do. So that finding those use cases is still very, very relevant and fundamental. Then we need procedures for transparency We need risk management that needs to be edited and added. So we have the things machine learning and generative AI needs to be included in those processes. And we need accountability when these are put into use. So those are conversations that need to be had in companies when adopting this technology. And then we still need the necessary conversations with the key stakeholders. So we develop something that is needed and serves the way it is expected and wanted to work. And then coming back to my area of special expertise, good data handling practices. All machine learning is only as good as the data, basically. So we need to handle that, and we need to know where the data has been. We need to know what has been done with it. We need to understand that and use governance practices in something that we handle the data well. And then finally, but maybe most importantly, is machine learning ops, which is basically a collection of all the practices required to innovate safely and to put these into use in a way that we are happy to use them for years to come. So what is new in this phenomena? Because there are things that kind of make me feel like Dorothy in The Wizard of Oz saying, "We're not in Kansas anymore, Toto." So basically we have these foundation models. They are very expensive to train. That would not be feasible, but they're offered for a charge, and some are open source. So they are available. We don't have to. We can just use them. And many of the big cloud players have this plug and play capabilities of these advanced models. So we can use them. So they can be brought to every company, every organization, and every consumer. We can use these with natural language, and so can our customers. So can our coworkers, so can our experts, helping them in their work to be more efficient. And then we have the hallucinations. Machine learning, it's predictive, so it tries to predict the outcome, whereas generative AI creates new things. So it is a bigger issue now to keep in mind. So 5 things to keep in mind when using LLMs. They focus on how language works. They're not focused on facts. It is not an expert system on the facts. It is an expert system on generating language. That is important to remember. All information is equal to the model, even if it is misinformation or deliberately misleading. It cannot really tell the difference. That's why it still needs us. And if it doesn't know, it will make stuff up. So humans are needed to make sure it produces output, it generates content that is of value. Don't give it sensitive data, or if you do, be very careful when you do that. That is always safe and good to do. And just keep in mind when using these and developing with these is that while the results can be seriously impressive, the model is still just trying to predict the next word based on what came before. Looking at the developing side of it, do you utilize the MLOps best practices? Or now there's a new term on the block, which is LLM Ops. So these are tools and techniques that help you innovate safely and robustly. Secondly, do think of what the role you want the LLM to take, and can it do that based on the logic of how it works. Thirdly, limit the access of the model and access to the model. So all those access to keep the solution safe. Fourthly is that the more the context the model has, the better the response, because the foundation models, they don't have the context. They are general, they know how language works, but they don't know the context of the business or the organization or the industry. So in that, it needs some help, and Jyoti will go into options on how to do that. So more context is usually the better, but not necessarily. Different wordings do produce different results. So that is the end of my introduction. I will next hand over to my colleagues Karthik and Jyoti. Karthik will look at navigating this Gen AI development and to bring strategic spark for lasting success, after which Jyoti will look at the implementation. But the floor is yours, Karthik.
Thank you, Satu, for a nice introduction of Gen AI. I know that the amount of material on this subject is quite of humongous, but it's nice that you put together in a very concise manner. And I have nice wind blowing through me so that I can sail through my next part of my presentation. And the next part of my presentation is more about presenting you all a blueprint of what Gen AI is about when we go for implementation. And here what I'm trying to, I've split my talks into two different parts. One is the usual way of how commonly we are seeing our Solita customers trying to approach Gen AI projects. And also one of our clients, Tana, also had such a Gen AI project venture, and we will try to explain very briefly how we went about doing such a POC project through the POC lifecycle. So Gen AI Rush is nothing but what I'm trying to aim here is that if you are captaining a boat and you have a destination, but you haven't thought of much more than reaching the destination, and there is more likely that you might have stormy waters ahead, and the ride is going to be rough, or at the worst case scenario, you may even sink. So in that case, how does it all start in a typical organization? And it starts, usually we have seen that it starts with an executive leadership strategic directive, because these are new topics which are coming into use which have not been there before. So there is usually a strategic budget allocated to it, and which is usually not too much, and it doesn't look into the entire life cycle of the AI solution. So as a strategic directive, you get as an implementation team that we need to explore Gen AI's potential in the organization's use. So that means that the CEO or the strategic board wants to know how we can leverage as an organization different aspects of Gen AI. And then once this is done, and then the typical journey begins, like then you have a team which is set up, which wants to look into these implications of Gen AI within the organization. And most of the time it's about first you set up some guidelines, and then you basically ask around from different business teams, are there any such projects which could be done through this strategic directive? And then most of the time you feel that you are constrained by the resources, because the Gen AI, the AI team, or the data scientist team which you have within, are already overloaded with different tasks, and then you basically check for external help. So the external help could be organizations like Solita, and many other organizations provide a similar help. And then you have a small budget, you do a POC, and you rush, and then you get something which works, which could be showcased widely in the media, and also to the strategic boards that indeed such things are promising. And also you will see that the integration also looks very promising, because you haven't went through the actual implementation, but it looks like you can get the data easily, and there are enough controls within the Azure or the Amazon system where you could put them into practice. And once this happens, this is the honeymoon period of your thing, and then it starts. Once you start seeing the outcome of this, then all the other data scientists or the budget runs off, and maintaining pace becomes very tough with other commitments. So then you also see that in haste you skip key processes. For example, what I mean by key processes, it could be many of them. The first thing is basically you forgot to consult the legal department. What are the implications of this venture when it faces the customer? The second legal thing is basically even the data. So who owns the data? Do you have the necessary data? What is the quality of data? And the most important thing we have seen is that you also forget to onboard the stakeholders with education. So that means that you provide the necessary educational resources to them so that they see the value in these novel technologies within their organization. And once this happens, this hastily things and the key process are framed, then you start realizing that that on a long-term success you are very far. That means that there is a gap emerges, and most of the time this Gen AI project, either you decide this is not for us, or you basically shelf it for future use when better days come. So the most commendable thing for such an AI development, you should be very happy that you have a very agile team which can execute projects at lightning speed. But the pitfalls, obviously, are potential operational challenges and lacking foresight because of unsustainable developments of such projects within the organization. And these are the important pitfalls to know, because they actually stop delivering, were the ones which stop you from gaining value from the money you actually spent on Gen AI. So to just summarize until now, I just want to write it in the Gen AI rush, don't let its potential hush. So what it means is basically in the rush to see the value, don't let it to hide all the potential things which can happen, and which you can get value from it, and then you stop the projects and ultimately stop getting value from it. So that's what this means. So now that you heard how a typical project runs in any organization, and of course we have many projects which we have run with clients, ongoing, quite many. And then we just picked one such project which we did for Tana, where we went through the entire POC life cycle, and I'll just give you a bird's overview of what went in each of them. So before I start, you must be wondering what Tana is. Tana is actually a family-owned business established in 1971, and they manufacture landfill compactors and shredders. I think some of you might know what a landfill compactor is, but just to give you briefly, it's an open area dump of solid waste where you continuously have to compact it so that you dump more solid waste, which is I think prohibited in European Union, but still an active practice in the United States and Australia and some other countries. And on top you see a typical shredder. What it does is it breaks down the complex solid waste like the tire and into smaller pieces so that you can segregate. And Tana is actually one of the world's largest producer of landfill machinery, and in fact they are in the top 3, and with an annual revenue of more than 60+ million euros. And they are a smaller company, but they produce huge machines, and their machines are working all over the globe, right from United States to possibly even to Japan on the other side. So for Tana, they had the strategic directive of they need to investigate what does this mean, because it's a technology first company and they want to bring the latest technologies to their clients. And we went through the strategic objectives of the company, and one of the strategic objective is customer experience. They want to provide superior customer experience to their customers, and so that formed a compass for us that we could go for using large language models. How can we deliver superior customer experience for their customers? So once we decided that it's a key strategic focus area, then we investigated what kind of actions helps them to get superior customer experience. Among many of them, minimizing downtime of machine is probably the most important thing, because these equipments are millions of euros. They cost millions of euros, and they need to work 24/7. So any minimum many downtime is a huge loss for the client. So in that way, so this was considered to be the most important thing if we can address through language models. And then one of the key parts of minimizing downtime is the people who are involved are the after sales team, because they are key to assure that minimum downtime, because they address customer queries and see that the machine is performing at optimal performance 24/7. And that's the place where we thought we could actually add value, and that's led to the birth of Tana GPT, which is nothing but a chatbot which is using all the information which Tana has about their machines and their previous queries from the sales service tickets, and how do we use that to address such queries as fast as possible. So before we go to, as I told you, education is one of the most important thing, because if our clients, a predominantly engineering company, do not understand what artificial intelligence is, or if they do not understand what generative AI is, and all our exercise is going to go to waste. So that's the reason first we thought we need to educate the general audience of the company on different aspects. We had a 2-hour course which was very basic, so that everybody understands in simple language, but at the same time we also made sure that we provided enough practical examples for their what generative AI can be for their company, for marketing personals, for the product design companies, for the finance customers, and also for the after sales team, so that we can we can provide this kind of sparks for them, so that they see that, okay, this indeed is revolutionary and it can help to do their business, to do their job better rather than replace them. So this is the main thing we wanted to communicate in the unlocking AI potential. So the next thing is basically a joint exploration workshop. We usually do this for all the customers. We want to understand what data they have, in what format they have, and is it readily available, so that we could use, not even now, but it has a long lasting availability for further stages in the life cycle of the Gen AI development. And also we want to understand what is it that the stakeholders are facing on a day-to-day life. That means that here the after sales team, what are their main problems and how do they want help, and this is what we want to understand before we create a solution. And we believe that this is the most important thing which usually people forget to do. And of course the next thing is the quality check. So that means that we see if the data sources are relevant, and do they have an impact on the generative AI we are creating. And these are the things we understood, and the linking between the different data sets we have. So we had a lot of things from many different, for example, from the manuals to the other documents. We have a lot of PDFs which we had to check. And then the most important, once we did all this, the POC could start. So we had multiple sprints. So in each sprint we generated one working version of this POC chatbot. And then at every time it was mainly about iterative risk reduction, because the customer wanted to understand all the risks and how to be mitigated before they go for the minimum viable product. So in that way, each of those cycles we went through, identified what's good, what is not good, and what's the risk of that this would not be adopted, and tried to reduce the risk each and every step. And so basically, I would say that these were the main steps. The main risk, there are many risks. So sometimes it's that the basic hallucinations were actually quite much reduced, but sometimes it's about multi-document hopping. And so among those, there are many things which had to be seen if the generative AI models can actually do them. So then at the last slide of my slide, I've tried to compile strategic, what I call here a strategic sparks, but one can already see this as a strategic beacons for lasting success for Gen AI. But this doesn't have to be generative AI specific. This could as well apply to any AI projects. So one of the most important things I would want you to focus is this prioritized long-term strategy. So what we want to convey here is that Gen AI development is not a sprint, but it's a marathon. So because there are a lot of things which are known, but there are a lot of things which are unknown. And this is an iterative test-based things that you try and you learn and you go ahead. And so don't give up so early. Have a long-term strategy that you will make it through, and then and you will ultimately see value. And define clear objectives, which is quite good, because here there was a customer experience was one of the things. And it's always good to know where you are going, so that as a ship, when you sail, you know where you end up. And to set up clear objectives, what you want to achieve, also helps you to create clear KPIs for your development projects. And the third, which is very important, is stay updated, because Gen AI field is rapidly evolving. There are tools, there are research papers, they are all the time coming. So you somehow would like to go through and read and see what is possible and what is not possible. Sometimes some of the things probably you believe that today it's basically not possible. You'll be very surprised tomorrow there is already a research paper or even a ready tool you can use to solve that problem. And so this is basically to say that it's a rapidly evolving field. And the most important thing here is also next is investing in sustainable projects. The sustainable projects are those projects which not only deliver value in a short term but have a long lasting impact and provides growth for you on a long term. But you can also see sustainability in terms of environmental impact to see where actually it makes sense to use generative AI, because there are already studies which shows about the environmental impact of Gen AI, and this could already impact on the carbon footprint of your business. And the most important thing next is the strengthening AI business collaboration. That means that there should be a perfect sync or symphony between the AI and or I would say technology and the business part of your organization. Once these two come together, then you start listening music. Otherwise, there is basically noise in the organization. And the second, the last is the robust infrastructure, which is quite important, because all this will not work if you don't have an infrastructure that is in place that can help you to scale this generative AI to the wider audience. And if you see, basically, if you're already doing machine learning projects, that means that you're already having feature stores, or you are already having MLOps solutions, as Sato was mentioning, and then not to mention the cloud investments you have made and all the bells and whistles that go with it. And these are already good enough, and they could actually be readily utilized for Gen AI things also. So you don't need that kind of investment for future, but make sure that you have good robust infrastructure with the data platforms and other things. And last but not the least, I would say learn from practical implementations. So it's very difficult for you, and every case is specific. You cannot wait for others to do work and then you learn from them. You need to implement your own AI solution, run through the POCs, run through the sprints, learn from them, and then you implement. Because this is, nobody knows what is the industry best practice it's about. We are learning with our clients, and that's how Solita has been able to gather a lot of knowledge, because we did quite a lot of projects both internally and externally with our clients. So this basically sums up my blueprint of what Gen AI has been typically in a general audience and for a sample customer we have had. And I know that you want to hear much more concrete technically now. So now I'm going to transfer my mic to my colleague, who will go through the technical implementations in much more detail, and so that we provide you much more value for joining us. Thank you.
Thank you, Karthik. Really excited to be here. So building upon what Karthik just said, like where he went through these Gen AI development life cycles, like beginning from figuring out like do we have really a business case where we can implement the Gen AI? Can we bring any kind of business value from the Gen AI? Do we have this good quality data? Like, do we have enough data for that purposes? Let's say that we solve that issues. We figure out the very good business case. We figure out that we have a very good quality data. But still, after that point, we have few challenges to solve, few questions to answer before we can reap the benefit of Gen AI. And that challenges comes from the LLMs. So if we recall what my colleague Sato said in her presentation earlier, that the large language models are trained on very generic knowledge, on very generic source of data. What does that mean? Like, they don't have any industry-specific knowledge. So what that means, again, is in this case, like when you want to build this Tana GPT, the large language model does not have any information about Tana's product, like what are Tana's threaders, what are Tana's compactor, or any information about Tana's after-sales service tickets, or so on. So if the large language model does not have that kind of information, so how can we use that model to have this kind of solutions to turn that generic chat GPT into Tana GPT? So we come up with, there is this efficient way, like we implemented to ingest this Tana-specific knowledge to this generic LLM, where now that LLM can use this industry-specific informations to generate the response to any user query. So that efficient method is called retrieval augmented generation. So this is a framework which we implemented to customize this generic LLM to our business case. So what is retrieval augmented generation? So this is a framework to retrieve relevant documents from our knowledge base and then pass those retrieved documents, those relevant industry-specific retrieved documents along with the user query to the large language model, where now the large language model can use that specific sets of documents to generate the response. So you have a knowledge base. That knowledge base can comprises of different industry-specific documents, and then you have some kind of retrieval mechanisms. And from that knowledge base, we retrieve the relevant documents and join it together with the user query and pass it to the large language model at the generation steps. So what does it solve is, now the large language model has that industry-specific knowledge at its disposal, so that it can now use that information to generate the informed or domain-specific responses. So how can we use RAG? Like, what other key problems this RAG addresses that are associated with large language models? The first one is knowledge cutoff. Like, as we just discussed with this large language model, now we can pass with this RAG approach, we can pass the large language model this knowledge-specific or domain-specific or the company-specific knowledge to the large language model, which previously it didn't have. So as a direct result of that, now the hallucination risk is greatly reduced. Now, since now we pass this company-specific knowledge to the large language model, now it can use that knowledge to generate the response to the user query. So it should not, so it doesn't just uses the generic knowledge it has to generate the response. So it has that now specific knowledge to generate the response to that specific query. So now the response generated by large language model are now much more factual. They do not hallucinate. Like, I will not say that it will eliminate, but they will greatly reduce these hallucinations. The next key issues the RAG framework addresses is black box functioning of large language models. So if you again recall, like what my friend Satu earlier said, is like large language models are really black box when it comes to functioning, meaning that when it gives us the answers to our user query, it does not return us the sources it used to generate that response. It does not give us what kind of information it used to generate that response. So we are in completely dark, like what sources it used to generate that response. So we can't verify by ourselves. Since we don't know the sources, we can't verify that whether that response is correct or not. However, the cherry on top with RAG is that it just does not give us the contextual responses. It also gives us the sources it used to generate that specific responses. So what it does, it brings that interpretability or verifiability in our solutions. So what it does is like it increases the confidence in the solutions given by the large language models. By the way, like there is also another technique which we can use to expand or update the domain-specific knowledge of large language models. The one being the RAG we just talked about, and another is called this fine-tuning. The key difference here between RAG and fine-tuning is that in the RAG, like as you just saw that we do not try to change this its internal meaning or its internal knowledge or its parametric knowledge or what we call the weights. Whereas in the fine-tuning, we change this parametric knowledge or the weights of the large language models. And since large language models are quite large, like meaning that they have billions of parameters, changing this parametric knowledge is quite expensive, like computationally, and also is time consuming. So the key difference with the RAG and fine-tuning is that RAG is much more flexible in adaptability. Like, since we are not changing its parametric knowledge, so if anything, so we are just sending it the domain-specific knowledge from our knowledge base. It's more flexible if to adapt when your knowledge base changes. Whereas with fine-tuning, if your knowledge base changes, the only way to provide that updated knowledge is to do refine-tuning. So, and the fine-tuning process is much more expensive and time-consuming. That might not be practical in every cases. Like, for example, if your knowledge base keeps changing, like you have those source documents which keeps on changing, like rapidly changing, in that case, like refine-tuning or fine-tuning every now and then with that document is really impractical. The next issue with these data freshness issues, and that again touches into like what if your knowledge base keeps changing? So like, how can we provide that fresh knowledge to the large language models? With fine-tuning, we saw that it's expensive and time-consuming. Whereas with the RAG, like only thing you need to do is update your knowledge base with the changed source knowledge. So it's much more flexible, and the large language model in case of RAG have this fresh data at its disposed. The another issue is the permissions on the data. I believe that in every organization, like not all the people in that organization has access or should have access to all the data. Like there is some kind of authorization, like who can have access to what data and who can't have that access to that data. So for example, and if we are going to build some kind of question answering over such kind of data, how can we provide this permission? Like, okay, this person can ask this question and have permissions to get the answers. With RAG, like we can provide this document level permission on the data. Whereas with fine-tuning, it's really impossible or difficult to provide this document level access permission or those role-based access control over the documents. And another issue is, like as we just talked also, it's about the adaptability and iterative improvement. With the RAG, it's much more easier to adapt to the user feedbacks because only thing we need to do is like iterate over the source knowledge and change a few components. Whereas with the fine tuning is like you have to fine tune again with your knowledge base. And another issue with the fine tuning is even after you fine tuning the large language model, the fine tuned large language model still function as a black box. So even on your fine-tuned large language model, if you ask any questions, it does not give you the source back. You are not still unsure like which knowledge it used, the knowledge it has previously or knowledge it gained after fine-tuning. So it's going to be a black box, whereas the RAG, we just saw that it gives you not only the solution, but also the source. So how does the RAG architecture looks like in hierarchy? So this is also the RAG architecture we implemented in Tana's case in making the Tana GPT, but this architecture is highly transferable. I believe this is where actually any RAG architecture or any implementation of the RAG begins with. So first we have this knowledge base. This, as we just discussed, this knowledge base comprises of different documents, like it can be from PDF file, or document file or SharePoint pages or a Confluence page, or it can be even your GitHub codes. So we have this humongous amount of data as a knowledge base. And the first step we do is we break that knowledge base, the data in knowledge base into smaller pieces, like what we call as chunks. Then after we divide those huge data into smaller pieces or called chunks, and then we do this what called the embeddings. The embedding is basically the numerical representation of those data. So we get those numerical representation of data like the vectors of numbers of certain sizes, and then we store those embeddings into the special kind of database called the vector database. These vector database are highly optimized for storing this kind of embeddings and performing the similarity search over those embeddings. So now we have the knowledge base. We chunk knowledge base into smaller pieces, and then we perform the embeddings or we get the numerical representation of those chunks, and then we put those into vector databases. That's one part. Now when it comes to like using that knowledge base, what happens is now when the user enters some kind of query or any kind of query, what we again do is we again get the numerical representation or the vectors, numerical vectors representing that text. So now we have this query and our knowledge base in very, very comparable format. Now they both are now are represented by numbers. So what we do after that is we perform some kind of similarity search. What that means is like we try to find the relevant documents in our knowledge base that are very similar to the user entered query. So that similarity search might be like semantic search, or where we not only look for the keywords in the user query, but also try to find the meaning of the query. So after performing the similarity search, we then retrieved top K relevant document, let's say top 5, top 7, or top 3 documents from our knowledge base. After we retrieve the relevant document, top K relevant document, what we do next is like we combine the user query and the relevant document in a single prompt. And then we pass that prompt to large language models. So what really happens here is that we augment that prompt, like we enrich that prompt that consisted of only the user query with the company specific knowledge or the domain specific knowledge in terms of the retrieved document. So we really augmented that prompt with the domain specific knowledge. So now the large language model has access to the relevant information to make the informed response based on that retrieved documents. So in case of Tana, our knowledge base included the various user manuals, technical manuals of their different machines. We also used their after-sales service ticketing data. We also used the solution source data, and we also used the error code description of the different data for different machines. And in terms of technology stacks, we use Streamlit Python framework for user interface. We use GPT 3.5 Turbo as our base large language model. We use this 3.5 Turbo from Azure OpenAI service. And we use Quadrant as our vector database. By the way, there are lots of vector database to choose from. For example, like there's Quadrant, Milvus, Chroma, Pinacons, and others. And to connect all this together, like to orchestrate this whole process, we use LangChain. And this LangChain framework has been gaining lots of traction nowadays when it comes to developing the GenAI-powered applications. So this is all about the architectures. So how does our solution looks like in this POC? So this is just one screenshot of the user interface of the Tana GPT. So we have created this conversational search interface, so where user can go and enter any query, and in the same interface, he can see the results. And as also discussed, this RAG framework not only returns the results, but also the sources. In the same page, the user can also see the sources. And on the side, you can see some selection tools, and we'll come back later in a couple of slides, like what does those selection tools mean and how they are advantageous. So not only the solution, but also the sources, like the key benefits of the RAG, and we can also see that benefit here in these slides. So for example, here the user entered the query, and the query was like, what are the key features in compactor display module? And then the model responded us with the the answers. And on top of that, it not just answered, but also it returned us the sources it used to generate that response. So in this case, the sources is like the file, which file it used to generate that response from our knowledge base, and not only the file, but also the which page number from that specific file it used to generate that response. So what it does is, again, like we briefly discussed earlier, that it brings that kind of trustworthiness in the solution. So if the user has now some kind of skepticism, or he has doubt on the response generated by the large language model, now he can go back to the sources it cited, in this case this PDF file and in this page number, and he can validate by himself or herself and check and see if the answer is really from these sources or model just hallucinates. So it brings that trustworthiness or the verifiability in the solution. And another thing, feature we included in this solution is these options to select the knowledge base. So on the side, you saw that different selection tools like the user manuals, maintenance manual, solution source, service tickets, and so on. So what does this mean is, like, it enables users to ask the retrieval mechanism to where he wants his answers to be searched for, like in which section in the knowledge base he wants the retrieval mechanism to search for the relevant documents. And this is really helpful when, like, for example, if the user has already some kind of idea, like looking at the nature of the questions, okay, for this kind of questions, the answer can be found in this kind of document, in this section of knowledge base. So he can really consolidate the search space into very specific data sources in the knowledge base. So when you have this kind of consolidated, when you have restricted the knowledge search space, what it enables, like it enables you to retrieve even much more relevant documents. So it even increases the quality of the responses. So this options to select has like greater impact also how the response by the models is. And another salient features of this application is that it comes with the memory, this conversational memory. What does that mean is, unlike the traditional chatbot, the application or the model in this case remembers our conversational history. So with this conversational memory of this conversational history, what it enables us is to like have this like human-like conversation. So just like with human, like when we have some kind of conversation, like we are aware of the context, like what we are talking about over what person or what places or anything like that. With this conversational memory, it also brings that human-like conversation, like this context-aware dialogues and context-aware conversation. So what does that again mean is, like, let's say, like, first question here is like, what is the recommended hydraulic oil label in the compactor? And then the model responded with the answers. And the follow-up question is, how about in shredders? And the model also responded with similar answers. Even though like we didn't explicitly say like what is the recommended hydraulic oil label in the shredders, but here the model understood from its memory, like it understood, like it inferred from the conversation history, because we have enabled the memory, like it inferred from the context, okay, this is what we are talking about, like this is what the user wants to ask about. So it inferred from its memory, it inferred that context to generate that response. So this memory really enables to have this human-like conversation where it enables to have this context-aware dialogue. And not only that, it also enables greatly enhances the user experience while using this application. Okay, that was about like how our solution looks like. So we developed the solution, we put it into the testings, the number of various different users tested it, and then we collected the feedbacks, and then we analyzed those feedbacks and saw like where our solution worked better, where it didn't work, what are the key issues we found out, when we didn't get the relevant response from the models. So we have like pointed out few points which we would like to share with you. So the first thing is seeking clarity, meaning that like if you want your model to give you a correct response, clear response, so should be your questions. Like there should not be any ambiguity in the questions. Meaning that in this case, like if the user is asking any question about some specific models of the machines, he should provide that contextual information, like what is the model number or what is the serial number, so that the retrieval process is much more better. The retrieved document is much more better. So provide the enough context in the questions. The next one is matching matters. Again, that meaning is like, okay, we have like very good questions. Now, how can we make sure that we retrieve the relevant documents from our huge knowledge base to answer that questions? So this really matters. Like this is like key issues in this RAG framework. Since like we have asked model to generate its response based on the retrieved document, we pass it through the prompt. The answer can only be as good as the retrieved document. So you have to very, very carefully analyze like how good is your retrieval mechanism, how good is the retrieved documents, how relevant they are to the user entered query. So these things really, really matters in this application. The next is information shortfalls, meaning that like you have like very good retrieval mechanism, like you are able to retrieve very top-notch relevant documents to any user query. There is still possibility that the large language model cannot assess that information, cannot process that information and generate that contextually aware response. So this also should be taken care into like, and like even after these relevant documents, the large language model might not be able to assess those information to generate those responses. The last is like, even though we didn't try this one, is this approach constraint. So here we use this RAG approach. It might be that like, it's not the question of whether RAG or fine tuning, like you might have to combine the strategy of both. So instead of doing the RAG, you might first may need to fine tune your large language model and do the RAG on top of that. So it really depends upon your use cases. And so here we just are trying to highlight is just that it might also be a possibility that you might need to combine the both strategy. So here we just discussed like some area like where the model might not work better, and here like we are going to say like how you can mitigate those issues, like how can you enhance the response of your solution, the quality of your solutions. The first stage is the retrieval steps. Like the retrieval steps meaning is how to retrieve the relevant document from your knowledge base given the user queries. As if you recall, the first step in the solution in the architecture was like chunking your large knowledge base into smaller pieces. So this chunking strategies really matters, like how good are your retrieved documents. So you have to try different chunking strategies. You have to try different chunking sizes depending upon your use cases for that precision retrieval. So for example, if in your use cases, like if the response that needs to be generated is of like very smaller sizes, maybe like you need to have a smaller chunk, whereas the response needs to be a bit more complex, maybe you need to have this a bit bigger chunk sizes. So it really depends upon your use cases and also how your document are structured. So you have to try different chunking strategy to have this precision retrieval. And another method is source method, like what kind of source method you have employed to retrieve the relevant documents. Have you only relied on one kind of search method, like nowadays mostly that uses the semantic search, like have you only relied on that, or you have also, depending upon use cases, you have also used other kind of search methods like the keyword-based search or the combination of both this hybrid search methods. So you have to try and test the different search method based on your use cases. The next step is document ranking. That means like even after you have retrieved the K number of documents from your knowledge base, you might have to again do some kind of post-processing on those retrieved documents, meaning that you might have to rank those documents and give them some relevancy score and then drop out completely based on the relevancy score before passing that to large language model. So you might also need to try this ranking approach. The next one is improved documentation, meaning that if your knowledge base keeps changing or has changed, make that change reflected in your vector database as well, because that's where we are searching for the information. So there should be this smooth pipeline of this changing knowledge base, that change being reflected into your vector databases as well. And the next one is embeddings, like meaning how we generated the numerical representation of those knowledge base. Like you might also need to try, depending upon use case, different embedding sizes or different embedding models. Like for example, if your knowledge base is in multiple languages, then you might need to use the embedding models which supports the multilingual embeddings. And also the embedding size, like what is the size of the vector embeddings you generated? Like either if they are too low, if they are too small, the meaning of the text might get lost during these transformations. If the embedding size is too large, like it might also include the noises during the embedding process. So you have to really try and test this embedding size depending upon your use cases. So these are the few steps like you can try at the beginning to improve the retrieval steps. And also about the generation steps, like sometimes there might be problem with the large language model itself, like the model you are using might not be like very suitable in your use case. So you have to try with the different models in your use cases. And another reason might also be the context window length. So the context sizes you are putting into the large language model might not be the suitable. So for example, the GPT 3.5 has this context window length of around 4,000 tokens, and in your case, like you might need to use the models which has higher context window length. So it really depends upon your use cases and where you have to try the different base large language models. All right, so this is few takeaway or a few points we shared with you from our experiences with working with a few customer cases, or in this case specifically Tana cases. So I will end my part over here and hand over the mic to Lasse for continuation. Thank you.
All right, excellent. As you can see, I brought my laptop here. There's so many questions on the chat that we're going to dynamically manage those questions. But before we get to the questions, a few closing words from me. I mentioned in the beginning that we take generative AI seriously at Solita, and hopefully we've proven now that we really do. We want to understand how it works, what are the pros and cons, the risks and the benefits involved in this as well. I want to point out one thing that Satu mentioned in her intro. The reason I'm excited about this is Gen AI is a little different than other AI because it makes stuff up. And that's exciting. It's terrifying and exciting at the same time. When previously AI was predicting sort of previously defined outcomes, now we're actually making up new stuff. And that's kind of exciting. So that's what we wanted to do today. Now, if there's one thing I want to mention to you today, it is that now is the time to start learning if you haven't already. We at Solita can help you with that. And there are some things that we talk quite frequently with our customers. And yeah, I'm just going to grab this one. This helps move the slide forwards. There are some things that we've been discussing with our customers. You heard just us present our case with Tana. But if there's one thing I hope you take away from this session, it is if you haven't already, now's the time to start learning, and start learning by doing preferably. We help our customers in just understanding the phenomenon, but also in applying these tools and capabilities. So we work with POCs and pilots like this. We also work with the architectures, governance models, and anything that comes along with how to organize and get ready for generative AI. But that's us. I mentioned that we would do the Q&A. So I'll invite my colleagues over here. Let's see if we can line up so everybody can see us on the screen. I'll try to manage the questions this way.
Can you the center also.
Yes, I like to be in the center. Cool. Now there's a whole bunch of questions. In the beginning, there were a couple of questions around the theme of validation. So how do we validate the outcomes? AI is hallucinating things. Satu, I think you had some points on how to validate outcomes of Gen AI.
Yeah, it kind of a lot depends on the use case, of course. Like in here with Tana, the user who gets the output, who sees the sources, can go back to the sources and do the validation and give that way. If an expert uses it to produce content, they can read it through. If both of these are not feasible, then some sort of, like, as is always advisable, to save the output of the model, and then some sort of random check can be built. And tools and methods of doing this is fastly developing.
Yeah,
But these are some methods too.
I'd also like to add on that topic. Like, we use two kind of validations in this case. Like, one is like human validation, like the person who is using can validate, and also we use this model-based validation. Like, it sounds maybe intuitive. So like we use the same large language model to validate the answers generated by another large language model. So there is also this model-based validations. Yes.
Right. Just to add one point to that is basically there is already a parameter which is called temperature, and by setting it to 0, we can already minimize quite a lot of hallucinations because it stops the large language models from being more creative. So the more creative it is, so the more hallucinated parts come in. So this is one way of minimizing the impact.
Awesome. Really good practical tips. So yeah, know the risk levels involved, and as you said, maybe you can use Gen AI to validate itself, but then you have to know what you're doing.
That's really that we use nowadays, like these model-based validations. Yeah.
I would still recommend at some point having a human look at it.
Of course, it's the combination of the both. Yeah.
Another big question, something you touched on it briefly, but we're all obviously eagerly waiting for what comes out of the EU AI Act. There was a question about how do we get ready, or how do organizations prepare for that? Any thoughts?
The first thing, as in this whole thing together, is to educate yourself and educate the people building these and using these, and the legal departments, to find out what's coming. And the AI Act isn't the only thing that's coming. There's going to be a Data Act and other regulation also coming. So keeping up to date and keeping the company educated is the first thing. The second thing is to look at the actual solutions that are in use or are in development, to look at what's their use case, look at the risk level, which is in the AI Act, and then start to build already the features that they need. So when it comes into effect, because we basically know the kind of what's coming, so you can already start preparing each solution so it's compliant when it comes into effect.
Right. I think one of the things that I was discussing with somebody is that this is the time to become friends with both your AI lead as well as your legal people in your organization. A similar answer, I would suppose, but there was a question also about how do we ensure that we stay up to date with everything that's happened with Gen AI. Kartik, I know you have some thoughts on this one. How do we make sure that we know what's going on?
So as I said, it's important that we all stay updated. But there are, at least I can share what I do. So maybe that's something which you can borrow. So for example, with the more business news, you always have a keyword search included on the Google News. So it always prioritize certain news with new technology. But when I want to read more in-depth things, either I go to a research paper. So I usually browse recent archives from the Cornell archive site, but for me what's more useful is the Medium as a web page. So it basically captures all the important things which I need, and it's concise and easily readable, and it saves me a lot of time. So I make it a point every day to spend half an hour reading through because I get an email of the list of most recent blogs written, so I make it a point to read every day. And apart from that, I always keep track of research groups all over the world who are renowned in certain topics. For example, for AI ethics and other stuff in Montreal, there is a research group. So I have subscribed to the newsletter. So they also send recent advances in certain areas to your email. So it's one way to capture everything. And of course, when the research paper goes big, so I try to copy them to the ChatGPT and try to make a summary of it so that I can read it faster. So these are different ways which I keep track, but you can choose what you like the most.
Any other additional habits that you would like to share?
Yeah, the same idea. Like I also keep like this email list where they can say concise like what has been happened recently, and it helps to update. And the domain is so huge that like it's really also difficult to stay updated. Things keep changing. So yeah.
I think also like even though the books don't change fast, but if this is a topic that is very new, then going through like the expert written books on the topic will help you get started. So then you can add the new information from like mail lists and Medium to a solid foundation. So you understand what is developing and how it works. So even though that takes more time, that can also be of use.
If I want to add one more, is also these webinars from companies like us, which gives you up-to-date information, and also the giants, the Microsoft, the Meta, and the Google. They have their own webinars and podcasts, and it's good to follow whenever possible.
There's been a bunch of quite sort of specific questions about the Tana case and Tana solution specifically. Maybe we'll try to address maybe one or two of those. One of them was, I think it's a hypothetical question. The solution now is not of real-time data, but if it was real-time data, how would you architect it differently? What would be your considerations if you needed to do something where the data is much more frequent?
Yeah, you need to have this robust pipeline to detect the change in your knowledge bases, and then run this whole pipelines of chunking and then indexing in the vector databases. So you have to have this robust pipeline. So if there is certain changes into the your knowledge base, you can detect that change and then do the same process step and update that knowledge base in the vector index as well. So basically, you need to have this robust pipeline to detect the knowledge change and process accordingly.
Yeah. Let's see, there was also questions about security, cybersecurity, and also like access control in this case. This was a company internal solution. How did you work through your cybersecurity and sort of access policies?
For Tana, it's a different game. So we made sure we understood quite early that we cannot use this as a front end to the customer. So it was mainly an internal chatbot, and right now we worked on mainly a data dump to prove the POCs, and maybe the further legal the security challenges is up for addressing yet.
Obviously, and we also need to have this strong authentication, authorization method, like who can use their services. Like Satu also mentioned earlier, that restrict like who can have access to that so that they don't misuse. Obviously, you need to have this kind of strong authorization and authentication to use that service.
Right. We'll do one more. I think this is a good one about risk of bias in the model itself, or in model-based validation, actually, as I'm reading this. How do we mitigate bias in the models, whether it is in the actual model itself or in how we're validating the models?
Yeah, for that you need to have strong guardrails. Like I think Satu also mentioned earlier, like you need to have these guardrails in the output given by the models. For example, depending on your use case, you have to make sure that if there is certain information contained in the output or not, or if there is certain information that should be in the output, it is there or not. So you have to have this, come up with the guardrails, and which will help to minimize this kind of biasness.
And I think gradually with feedback loops, we gradually recognize the bias. So it's also not possible to recognize all the bias immediately. But then using the feedback loops and trying to make sure the guardrails are robust enough, so we make sure that it serves them. Yeah.
And here also the generative AI helps. So once there's at one point you need some human to notice that, okay, this is biased, and then that can be marked, and this is biased, this is problematic, and then you can keep on like updating and looking at the model, and this is what the big operators also are doing to kind of mitigate this problem, but also in like fine tuning and stuff. If that is utilized, then you can use the problematic output it gives to make it better in the future.
It sounds like there's definitely some sort of new skills and roles and responsibilities involved in doing the validation itself. So that's a big theme I think we take out of this.
Absolutely.
Yeah. All right. Well, thank you, my colleagues. It's been really insightful. I've learned a lot as well. Hopefully everyone there has gotten a view of what it means practically to do things with Gen AI. The one final word I'll mention is just briefly mention that in about a month from now, we will do our Solita Summit, and we'll again get back to the theme of generative AI. So we've titled it Beyond Gen AI and Hype. We'll have customers and partners talking about their approaches to generative AI. So tune in for that session on October 24th. Put it in your calendars. You'll get invites from us, I'm sure. But thank you everyone for this morning. Hope you have a great Wednesday, and we'll see you at the Solita Summit in October.
Thank you.
Thank you.
Thank you.
Pleasure to be here. Yeah.